look at it here. So yeah, actually, for aggregated functions or for grouping by, you will have to basically give this entire condition itself. Or you can probably create a table out of it, and then on that table you can put this particular condition of weight group. Okay, so let's say if you are putting for 175 or under, or let's say if you are putting for this particular one when it is 201 to 250, right? So this particular condition itself, as it is, we can give here in the where statement, and this should work. Or you can use the between operator as well here. So here, if you'll see, all the weight groups will be between 201 to 250. Okay, similar kind of operation you can also do on the height column, on the height column which is here in your main data. Okay, so we were here, then this is again, you can take multiple strings, multiple criterias. So if you are, instead of doing only on one column, so we have multiple columns here, right? So yeah, you can similarly kind of create groups between height also to divide the students in groups. Now I'll just write as case when on multiple columns. So what is happening here is they're just taking player name, and after that they are taking when year is equal to FR and similarly position is equal to WR, then they want to make it frost WR, else null. So this way they can filter for these particular use case. Basically they can create kind of a flag. This flag will help them to identify whether these many frost WR are there or not. Okay, the same thing they can also do by using the where condition on this one. That way you will be able to filter the data, or if you want to create a column, for those cases you use case when statement. All right, so if I just run this particular part, then is gives, okay, these many people are frost WR here. Okay, cool. So yeah, this is this one. Then there's the basics. They're just revising it here. On aggregated functions, if they want to do it, case when on aggregates. So this is the condition that you're using year and not FR as year group. FR, that I think is for frosh. So there's trying to identify whether it belongs to that or not. And then they're just grouping by the same one. Now let's try to look at how the results of this look like. So it's the same thing. If you'll try to see here from case 1 till not FR, it is exactly the same thing which has been used here, right? So instead of giving this year group column, they are just putting in the condition. So the same thing that we saw here, right? When we are trying to put the where condition, they will have to write the entire thing. In a similar way, they are just using the same thing here. So here, if we just have to write this entire thing, then we'll just do a case when, and for specific groups, we can basically filter it. But yeah, what is happening in group by here is once they haven't taken any column here, the only column here is the count column. So if I run only this much query, if I'm skipping this particular line, so it won't work because they have taken this count one as count column as well. Okay, so probably let me just comment it and let me try to run this part only. So it'll just give me the number of rows which is not FR, not FR. Probably if I would have taken the player name as well, then it would have made more sense. But yeah, now since once you have this, what you want is you want to count it, like how many are there, right? So count of this, whatever the first column as count, and then you're using this group by query giving the same condition. Okay, so now if I just run this particular part, then not FR we have around these many, and FR we have around these. Okay, and the summation of these two will be basically the total number of rows in your data set. Okay, so this is how you can use group by along with this. You can probably use having also here, having a particular value equal to or greater than, let's say for having EL group equal to FR, that also you can put. Okay. Now you might be thinking, why wouldn't I use a where clause to filter out the rows I don't want to count? So it will look like this: select one as FR count from this, where year equal to this particular one. So this is in that case if it has got created. Okay. But what if you also want to see a couple of other conditions? So this is the overall condition, and then you're just grouping it by one, right? The one is basically the entire thing here, the first one. So this is again the same query, and this is the longer form of this same query which we are using it here, right? Now this is combining case statement with aggregations can be tricky at first. It's often helpful to write a query instead of case statement first and run it on its own. So you can, yeah, it is just giving the same thing. So now let's look at how to use the case inside of the aggregate functions. All right. So if I just look at this particular query, it is just creating a year group. This is no year data. And then this is counting it. And this basically this whatever query that we have written here itself. So let me give it a heading of case inside aggregates. Okay. So if I just run this particular part, here it is just doing multiple case when statement to create year group, then this counting this particular one and this grouping by one. So for each of the year group, you'll just get the counts. All right. Now what it is saying is reorient it horizontally. So if I now write this, this probably won't work because this has to come along with it. But let's see. Okay, yeah, it should work basically because it is just creating these columns. So you saw the same thing column wise, but then if you just count the columns, right? So these whatever case events are there, FR then one else zero. So it is, okay, let me show it this way. So here what is happening, it is taking the entire data, and for entire data you will have these in multiple rows, then it is just grouping by it so that you have one more column which is just takes the count of each of these, right? So your data, you got just one column. Now if you look at what is happening here, then it is creating one column. This column it is creating is case when year is equal to FR then one else null. So it is creating one FR count column and it has 101010 values. This is one entire column. It is just counting it. It is giving it a name FR count. So this FR count will be same as this 9665. So if I just run it again, similarly it is just using sophomore count or junior count or senior count, right? So you can see that 9665. So I mean, the thing is that overall, when you will start writing complex queries, right, you will see that case when gets used a lot, and it is a little bit tricky as well. You will have to practice it a lot. other than this, I think I had shared a link of different practice exercises, right? In the blog itself, blog format itself. So from there, I would suggest, other than this one, other than whatever is mentioned in this particular page, try to practice it from there itself. But yeah, so yeah, then there are just multiple problems here. So this is your overall case statement related queries. But yeah, it in day-to-day operations, right? Case when gets used a lot, and it makes it really simpler for writing complex queries. Instead of writing complex queries, you can just in simpler format use it, and try to look at different use cases of it. Use cases in the sense, um, different examples of it. Like let's say we are just trying to put it in here. Just try to replicate them for a different table probably here, and from the practice exercise itself that I had shared. Okay, so we are done with these many, and we have joins. So now let's look at joins. We probably have around 15 minutes. So yeah, this is just joins. Then this is aliases in SQL, join and on. So yeah, this is how you can put a join condition. Let me just take it here and just give it a heading here. Yeah. So what exactly is happening here? This is just, if we'll just look at it. Okay, let's first look at the aliases here, how the aliases are. So let's say you have two tables. Then on those two tables, there is this common key, which is school name. Okay. So you will basically join them on school name. Now this school name on this particular column might have, in one particular table, might have a different name. It can only have school, and the other one it will have school name, right? So the on is basically used for finding out on which particular column you have to join these two tables, right? So it'll come up in the structure. What it'll do, it'll join all the rows from this players table to all the rows in the teams table, where school name field in the players table is equal to school name field in the teams table. All right. So this is how it does it. So when you say join here, right, then it basically means if it is only join, then it will be a full join. Every value of this particular column to every value of that particular column whenever they are equal. All right. So if I just put it. Okay, first I'll put this, then we'll probably try to look at the other one that's kind of more complex. So let's try to look at it. Select star from this one, join this one on teams. This one you are named as teams. You just have given it this name, or you can give this entire name as well. This entire name dot school name. Then similarly for players, you can give this entire name dot school name, but you just given aliases. Now what aliases is a kind of a small temporary name that you've given. It will just be used inside this particular query. So before doing this, let's first look at the initial structure of these individual tables. I'll just limit it to 5. And let us start writing the query for the other one as well. So this one is like this, and yeah, so this is the same one which we are using for our calculation. Let's look at the college football teams. This is college football players. Then this is for each of the school, what are the football teams. So we know Cincinnati, right? And that the roster URL for it. then ID, then conference, then division. Now they just both want to collate these tables. And if you try to look at these columns were not there. And this roster URL also were not there. This ID column was there, but yeah, we can probably connect it on ID column as well. Okay, if they both make sense. Now we are just joining it here on school name and this. So I'll just run it. Okay, so this is school name, duplicate column name 1. Okay, this is the full school name. And then you have the school name here, whatever was common one. Okay, whatever column, whatever table that you give first, that will come up first here. Okay, and whatever this college football teams was there, it has these many columns, right? ID, roster URL, school name, conference, division. So this is coming now. Now ID was also getting duplicated. So this is ID and this ID duplicate column name 1. Now as you can see that it is getting repeated here. So ID 1 of it is multiple IDs of this. So what that means is that these both ID columns were not similar. They meant different things. Okay. I mean, it makes sense, right? Because one is ID of football players and the other one is ID of football teams. So they can't really be equal, right? Because one football team can have players with multiple different IDs. So yeah, this is just a simple join here that we are doing. Now let's try to look at different formats of it. So yeah, this is just a joins. Now let's try to look at inner join. Now what inner join will do, it will just look at the common values. Okay. So let me just do this. SQL joins. And let's look at this images here. Yeah. So this is some Stack Overflow question or answer. So this is your inner join. Okay. So try to visualize it. You have a table A, you have a table B. There is some column on the basis of which you are, like trying to join these two tables. What this will do, this will give you only the common values. This is your inner join. Then let's say you have this table, left join table, and you want only whatever school names are in this. Let's say this is the school name column and this is the teams table. This is the player table, this is the teams table. You only want the schools which are there in the player table to appear in your final data set. So in that case, you'll use a left join. If you want only on the teams data set, whatever school names are there to appear in the final data set, then you will use right join. Okay. Now, this particular one, you want whatever is common. Whatever is in A, you don't want it to appear at all. Okay, only whatever is there in B, you want it to appear. Then you'll join them and you can just put A dot key is null. Okay. Similarly, if you'll this will be for left join for where B dot key is null. If you want a structure like this, so just try to understand this structure. Here the condition that is given is select list. This you can do anything, whatever number of columns or whatever you want. From table A, left join table B on A dot key equal to B dot key. Until this part, we are exactly aligned with whatever we are doing it here, right? We are exactly doing the same thing here. But after that, there is putting one more condition where B dot key is null. So in our case, we'll put this one and after that we'll write the condition as where players dot school name is null. Right. So if I'll just run this particular part, then it will return me those rows where it is null, but it looks like it's not null anywhere, so it hasn't returned any data. Okay, now this is your just full outer join. This is what we are doing here. We are not putting any kind of join, so it by default means this. And then you have this one where you only want to exclude the common values. You wanted to return the values which are there in this, you want to return the values which are there in this, but whatever is happening here is just the opposite of this, right? Just the opposite of this. Okay, now let's try to look at it in the practical format. So this is your inner join, and you are trying to collate the, yeah, so this is for players.star, this for teams.star. If you want particular columns from here, then let's say the first column name is A, then the second column name is players.b. It'll just give you only two columns from this. And similarly, you can do the same thing for teams columns as well. But yeah, if you want all the columns, then just use star and like select players.star, teams.star. This part is same. So this basically we just have done it, but yeah, this should be basically inner join here. So this will give you only the common values which are there present in these two tables. Okay. Okay. Now one more thing, one more variation of it is this. Okay, I think yeah. So if you're using players.schoolname, then you can write as players school name. Then similarly teams.schoolname, you'll write as teams school name from this one. And then again the join on this particular table and on these two particular columns. Okay. 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 One part which I told you, I'll just try to correct it. If you are using only join, then it doesn't mean it doesn't mean this one. It basically means the inner join only, basically for the common values. Okay. So you can either write join or you can basically write inner join. So both will return the same things. Okay. So yeah, this what we are doing here is we are just giving alias names. We are just selecting two columns after the join has been performed, and you can see that names will be exactly equal because we are just joining on these two column names itself, and we are just doing an inner join here. Okay, so this is your inner join. Now let's look at outer join here. So yeah, this is the inner join, this left join, right join, this outer join. So they're trying it on the Crunchbase data set. Okay, I don't know why they haven't. They've given the header, but they haven't given any query for this. But yeah, in a similar way that you use inner join here, right? You can just use an outer join, and the output table what you want is something like this. Basically, all the results which are present in both the tables for this common set of IDs, right? So even when so try to look at it in this way. This particular part, if you just try to look at this particular part of A, then it does not have any values of B, right? Any keys where B is also present. Only this part has the common values, and this part has all those values which are there in B but not in A. So let's think of it in this way. Let me try to explain it in a simple way here. Okay, I'll just delete this part. Okay, let me try to explain it in a simple way here. Let's say you have a table A, and the table A has around 40 different rows, right? And the table B has 45 different rows, and they have certain key on the basis of which they can be joined. And now if I'll use A union B, right? Sorry, not A union B, I'll write A intersection B. A intersection B, let's say you have around 10 values. Okay, so these 10 values are common across both of these tables. Okay, let's say you are trying on some keys there, some particular keys there, and this particular key is common for both of them, for both of these tables. Let's say this has a list of schools only. Table B also has a list of schools, and there are only 10 common schools. Okay, now if you'll do a full join, in that case the total number of rows that will be returned will be basically sum of 40 and 45. All right, so it will be basically 40 plus 45 minus 10, right? Because these 10 ones are common. All right, so this is how you will get. If you will, so this will be the result of outer join. Okay, and if you're doing table A and then you're always putting table B later, if you're doing a left join, then you will get only the keys which are here, which are around 40, right? If you'll do a right join here, then what will you get? Only whatever is there in table B. So it'll be 45. And if you'll do an inner join, then you'll get 10, because there are only 10 common rows in between them. So this is the overall concept. The implementation part is easy. Instead of outer here, you can just put inner, or you can just put left. So this is how the entire syntax of it is like. You select everything from, then you give left join to whichever table name on this, and you can put multiple conditions here as well. And on, and you can give multiple different conditions, multiple basically different column names on the base of which you want to join. Okay, so yeah, this is the concept of joins. We'll try to further explore it in the next session, so that we can understand it in a more better way, because joins are used a lot in data science and in general data analysis and pulling day-to-day data and just performing different queries. So does anyone has any doubts? So we are done with today's session. So those who do not have any doubts can drop off, and those who have any doubts, you can stay back and ask your doubts. Okay, so if there are no further doubts, then I'll just close the session for today. For more practice problems, which website is good? So actually I had put the link here itself, this one. So I'll just select, I'll just go down here. We have SQL exercise here. I'll just click on this, and so these are just the exercises of week, but I had put this free SQL exercise and resources, basics to advanced. So I'll just click on this. So I'll just tell you which ones are which level and all of that. This is just a quick guide for a kind of a recap. Then this is the link of mode where we are doing all our classes. Then on viceall.co.uk you will get some good exercises. In Ramkedam you will get skill exercise for data analysts. Like they have a really good set of proper business oriented exercises Then on HackerRank, you have good set of exercises. Mode itself has, this is just a tutorial part. W3 Schools is like very basic. On DBA Exchange, you can find out, you'll have to just filter for most votes or something, and you can find actually some use cases, real life, real industry use cases in this DBA Exchange. So this is RAMKDM, and here let's say if you're on flight analysis or Facebook games analysis, movie ratings analysis. So this just gives you a table frame. These are the rating ID, member ID, and movie ID, and you can just try to solve it. You can look at the discussion as well if you want to get a clue of how to do it. Okay. So yeah, is there any difference full outer between outer join and full outer join? So this is your full outer join. Yeah, this is your full outer. Yeah, I mean, yeah, there is not much of a difference between outer join and full outer join. It's basically the same thing. So here it is just full outer join, and if I'll just go here, there is mentioned this is outer join. So it's the same thing. Okay, cool. So if there are no further questions, we can probably close the session for today. Thanks everyone for joining.